Hello everyone, welcome to Machine Learning with Python Package TensorFlow Episode 3. So before we start, you're going to want to find your Anaconda prompt, and you're going to do conda install. Hold on, I need to find the package. So when we open Jupyter Notebook, I'll show you the packages you need. So you're going to want to do conda install tensorflow underscore hub. And then the next one, you'll have to do pip install tensorflow underscore datasets, and press enter and just say yes to whatever needs to download. And that's how you'll get these imports to work. Otherwise, we're just going to import NumPy and TensorFlow, and we should be all good. So let me find my lessons. Lesson 3. So today we're going to work with text classification. So we have a ton of movie reviews on IMDb, and they're either say the movie is good or the movie is bad, which we have as a unit value of 0 if it's bad or 1 if it's good. And we're going to make a machine learning model that studies it. So let me split my screen. And then we're just going to say import NumPy as NP, import TensorFlow as TF, import TensorFlow underscore hub as hub, and then import TensorFlow datasets as TFDS. Shift enter. The computer will run this. So, like always, you're going to want to split the data into training and your testing data. So, what we do, once it's loaded, we're going to say train. We're going to create some objects, so train data, comma, validation data, comma, test underscore data is equal to tfds.load, parentheses, and I'm going to say name equal, and in quotes, IMDb underscore reviews, comma, split equals, parentheses, and in quotes, train, bracket, colon, 60%, comma, quotes, train, bracket, 60%, colon, and then comma, space, quotes, test. And then comma outside that parentheses, but still inside the first one, as underscore supervised equals true, with a capital T. So shift enter, name is not defined. Oh, I didn't put an equal sign. And yeah, sorry it's hard to see. Let me see if I can. There we go. So we have the train data, the validation data, and the test data. So train has up to 60%, validation has the other 40% of the test or the training data, and then test data has the test data. And so now, just to see what the first, say, 10 examples are, just type train underscore examples underscore batch. So we created a variable. We're going to set it equal to, actually, we need 2 another variable, train underscore labels underscore batch. So we created two variables, the train labels and the train examples, and we're going to say next, quotes, itier, quotes, train underscore data dot batch parentheses 10, and then below that we're going to print the train examples batch, and you can read the movies. I don't know what movie this is actually for. This is just I don't know what it's for. You can see it's lots of text, and so then we're going to print the train labels, or the first 10 train labels underscore batch. Shift enter, and you see it's 0 for not a good review, 0 for not a good review, and so forth. Alright, so on to training the model. So all of this is taken from TensorFlow's website. This is the second Machine Learning with Keras text classification. But in it, they use this, I don't know, like a model, token-based text embedding trained on English Google News, 130 gigabyte corpus. And so basically what this model does is it looks at text and splits it up, and then it's able to determine what the words mean and learn off of it. And so it's very interesting. So it takes a batch of sentences and a 1D tensor of strings as input and processes it input by splitting on spaces. And yeah, it's pretty cool. So we need the link to this swivel or model for it to work. So we create a variable called embedding, and we're going to set equal to the link in quotes. So see this just to save time. And then we use that to create our model. So we'd say hub underscore layer is equal to hub dot Keras layer parentheses embedding. So that's where the link will go. And then input shape, you don't put anything in there. Just brackets, comma, and then data type equals to tf.string, comma, trainable equals true. Okay, so here we're like testing the we're just practicing with the model. This actually isn't, this is really just a test layer. So hub layer parentheses train underscore examples underscore batch brackets :3. So this outputs data. I think it represents just a sample type of how well it kind of used the data. So I think it's just showing like what the model predicts in numbers for these first few batches. But this is not the model just yet. So down here, now we build the full model. So we're going to say model equal to tf.keras.sequential brackets or parentheses, and then rather than doing what we've been doing, we can just say a model.add parentheses hub underscore layer, and then model.add tf.keras.layers.dense parentheses 16 comma activation equals parentheses Lulu. And we say model.add tf.keras.layers.dense input 1. And then we're going to say 1. And we're going to say model dot summary. So let me go back to this and see what that was, because I was a little confused by it. But basically, for this example, we're using a pre-trained text embedding module, and so we're creating like a Keras layer that uses a TensorFlow hub model to embed the sentences. So that's what we were doing with the embedding and hub layer. And so we add that in there, and then we add dense 16 activation equals relu, and then tf.keras.layers.dense1. And yeah, so the first layer is just the tensor hub layer. This is the one that splits the words. The second layer is a fixed length output vector that's piped through a fully connected dense layer with 16 hidden units. And the last layer is a densely connected with a single output node. That's because we only want the model to predict a 0 or a 1. Shift enter. So we say the model is sequential, layer type, output shape, parameter. We have the Keras layer, none 20, parameter 40,000 or 400,000. We see the dense, none 16, 336, dense 1. So yeah. So since this is a binary classification problem and the model outputs logits, we'll use binary cross entropy, a loss function. So this measures the distance between probability distributions, and basically it just predicts 0 or 1. So we say model.compile parentheses optimizer and equal to quotes Adam, comma, loss equals to tf.keras.losses.binary cross entropy. Like always, be careful with your spelling. These are long words. Parentheses from underscore logits equals true. Comma, enter, metrics equals brackets, quotes, accuracy. And shift enter. So what we did is how we compiled it. We want it to predict 0 or 1, but the metrics accuracy, that's just going to print the accuracy when we fit the model, and then optimizer is set to Adam. So now we're going to train the model for 20 epochs in a mini batches of 512 samples. So we say history equal to model.fit, quotes, train, underscore data dot shuffle, and 1,000 dot batch 512, comma, epochs equals to 20. Space validation underscore data is equal to validation underscore data dot batch quotes 512 or parentheses 512 comma verbose equals 1. So what we're doing is we created a object and we're setting it equal to the model.fit in this particular train. So history here is just another model that we want to see how well it handles the training data and the validation data. So this is just another model that will fit to it. So shift enter to run. And here you can see the accuracy. Just wait for it to finish. Alright, so it's about to finish. There we go, all finished. So we see an accuracy of 0.92 with a validation loss of 0.30 and a validation accuracy of 0.86. So now we can see how the model will really perform. So we say results. We create a variable called results, set it equal to model.evaluate, parentheses, test underscore data dot batch, parentheses 512, comma, verbose, equal to 2. And then we're going to create a for loop for name, comma, value in zip, parentheses, model.metrics underscore names, comma, results, colon, print, parentheses, quotes, %s, colon, space, %, 0.3f, and then space, outside of the quotes, %, parentheses, name, comma, value. So here we created another model that's equal to testing the model with 512 mini batches, and we created a for loop that says each time you run it, print out the name and the value. So shift enter. Actually, it should only run once it's done. So of the 49th time, we had a loss of 0.31, we had an accuracy of 0.85, and so it's actually lower than the training yet again, which is very interesting. So we'll see later on how to deal with that. So yeah, that's this tutorial. So again, just import the data and split the data. And here we just see the first 10 examples. And then this time we had to embed a special function that will allow us to split the words in the input. And then here we just set model equal to keras.sequential, but we use the model.add function to add the layers we want instead of one big messy thing. And we compiled it yet again, which is just the same thing we've been doing, just a little differently. And we fit it just like before. And this time you see we create models, we create objects that hold the models, and you can do that. Machine learning is all about just creating models and using models. So thank you for joining me.